let's see where we are on Ariane. I think we have a picture of Ariane in its final integration stage. Yes, this was taken 2 weeks ago. This is the Ariane which we're going to get launched on, and this is the upper stage being put on it. Now, again, this is something unique for the ATV mission. Normally, when Ariane is taking something to a geostationary orbit, it only fires the upper stage once. We, however, will use a reboost of the upper stage so that we get eventually into our circular orbit. So here you can see the final integration. And as I said, that's all going to be ready, and they will also be ready to go to the final integration building by the end of next week. For those people who don't know where our launch site is, here we have a map of the world with Kourou. This is, as I said, French Guiana. In fact, it is part of France. It's a department of France. The great advantage of this is that it's virtually on the equator. It's 6 degrees north. So for any launch, you get a real boost by the spin of the Earth. So it's a very nice place to launch from. Right, now we'll just have a look at what makes up the mission from the launch until we get to the space station. Here we have the Ariane launch coming out of the jungle in South America. As I said, this has been especially strengthened up to take the very heavy ATV payload. We obviously lose the 2 solid boosters, and going on the main cryogenic stage before we release the fairing. Once we then get off the main stage, we do this first firing of the upper stage, and as I said, then here's the upper stage, and eventually after we'll circle once around the Earth and do the second reboost to get us into this circular orbit. Once we've separated from the upper stage, obviously the first thing that has to happen is we have to get power and communications. So the solar arrays deploy, and also we deploy the antennas so that we can talk to the satellites and to the Earth. So here is the characteristic 4 solar panels, each with 4 wings, with each with 4 panels. And now once we get to about 300 meters from the space station, we start to use this optical guidance of these lasers, which are reflected off the targets which we put on the back of the space station. We have these, this is the primary means, which are called the videometers. But as I said, we have this completely independent teleganometers, which if they see us going off track, they can send us away from the space station. So we come in from this 300 meters, we do a sort of dance with the space station. They're under their own control system, we're under our control system. We're like a pair dancing on the floor. And so we come in very, very slowly so that we do not collide at under 10 centimeters per second. You can see here the Russian probe extended, which will be caught by the service module, and then we'll be pulled in to make the joint rigid, like any other docking vehicle. This same docking mechanism as both the Progress and the Soyuz have. So that's the mission from the beginning to the end. I think I've tried to give you some idea of the complexity of this spacecraft. Not only are we the largest